All right, so we are on page 164. And we are going to use this graph about roller coasters for number 38. It says, represent a problem. Each car on the steel force train has 3 rows with 2 seats in each row. Okay, so I'm imagining 3 rows, 2 seats in each row. Right? That's kind of what that looks like. How many seats are on the train? Draw a quick picture. Now, we're only looking at the steel force train, so I'm going to focus my attention on the graph to the purple bar. And I need to know how many cars there are. And the graph tells us cars per train up the side. We see the scale, it's counting by ones. So I can count up by ones, 1, 2, 3, 4, 5, 6. Or I can look at the 6, go across on the line, and see that the steel force train has 6 cars. So my quick picture, I'm going to make 6 cars. So I'm imagining the 6 cars. Inside each car, it has 3 rows with 2 seats. So it has 3 rows with 2 seats, 3 times 2 in each car, right? And I have 6 of those. So I've got 3 times 2, 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 3 times 2. I need to do 3 times 2. 1, 2, 3, 4, 5, 6 times. This is my problem. So I can think 3 times 2, I'm just doubling 3. It's like 3 plus 3, right? That doubles back. So it's 6 times the 6. That's going to be my answer. So I need to roll my 6s. 6, 12, 18, 24, 30, 36. 36. So 3 times 2 is 6. Take that 6 times 6 is 36. The parentheses helped me. The picture helped me. All right, for number 39, there is a separate video. I'm going to have you watch the Go Math video, and the gentleman in the video shows you two ways to solve problem 39. Together, we're going to look at number 40. And number 40 says, we're going to go deeper. Sense or nonsense? All right, as mathematicians, we are thinkers. So let's think, is this sensical or nonsensical? So each week, Kelly works 2 days for 4 hours each day. So 1 week, there's 2 days of working, 4 hours each day, and earns $5 an hour. Now that's Kelly. I think I'm going to need different colors for this. Kelly is working 2 days a week, 4 hours a day, $5 an hour. Now I'm going to change colors. Len, works 5 days for 2 hours each day and earns $4 an hour. Kelly says they both earn the same amount. Does this statement make sense? Explain. So first we need to find out how much each person makes. So Kelly is working 2 days a week, 4 hours a day. So I could think that might be 2 days times the 4 hours, right? And so that would be the total number of hours. And each of those hours, Kelly is earning $5. So I'm going to multiply that by $5 to get Kelly. Now, Len is working 5 days for 2 hours each day. So this is the total number of hours and is earning $4. All right, the parentheses help me kind of organize my thinking. So Kelly 4 times 2, I know that's 8. 8 and times 5, I can count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So Kelly's earning $40. That's Kelly. Now let's take a look what Len is doing. 5 times 2. Oh, I can easily double 5. That's 10. 10, I can count by 10s 4 times. 10, 20, 30, 40. $40 is how much Len earns. Kelly says they both earn the same amount. Does this statement make sense? So, did they earn the same amount? Are these two numbers the same? And does it make sense? So I will say yes, it makes sense because 2 times 4 times 5 equals 40. And I'll put my dollar sign there. And 5 times 2 times $4. Oops, I'm going off into the margin. Oh, you can't see that, sorry. Equals $40. Let me let you see that. And I'm noticing something as I'm writing these out again. I'm noticing there's 2 in this problem. There's a 4 in this problem, and there's a 5 in this problem. I'm going to use this handy dandy space they gave me to show my work. I'm going to just write these problems out again. 2 times 4 times 5. And I'm going to take the dollar signs out. And, whoops, I switched colors. Sorry. That 2 times 4 times 5, pretend that's black. This is Kelly. 2 times 4 times 5, right? And then Len's is 5 times 2 times 4. I've got the same numbers. I'm just multiplying them in different ways. If I had just moved these parentheses, I could reorder these numbers, right? If I moved this around and made Kelly's go this way, if I move this 5 to the front and make it 5 times 2 times 4, right? Then I've got the numbers in the same order, and you can tell I'm just moving those parentheses. I can either do the 5 times 2 first and multiply that times 4, or I can do the 2 times 4 first and then multiply that times 5. It will give me the same answer. So that associative property is telling me that I can change the order that I multiply my factors and it will give me the same product. All right, number 41. Think smarter. Clayton packs 3 boxes. He puts 3 lunch bags in each box. There are 4 sandwiches in each lunch bag, and there's 3 lunch bags. How many sandwiches does Clayton pack? Show your work. So I'm a big picture person. I'm imagining, here's my 3 boxes, right? Those are my 3 boxes. And I'm going to have the 3 boxes. Inside each box, I'm going to have 3 lunch bags. I'm going to draw 3 circles to be my 3 lunch bags. There's 3 lunch bags in each box, right? So that's 3 groups of 3. You can see that. 3 boxes with 3 bags in each one. 3 times 3. Inside each lunch bag, inside each red circle there, I've got 4 sandwiches. I'm going to just use the numeral 4. That's going to be easier because I made them very tiny. So I've got a lot of 4s. I could think I'm going to roll my 4s, right? I'm going to multiply these by 4. So I'm going to use my parentheses. I'm going to do the 3 times 3 times 4. I could do it that way. Or I could think, look, yeah, I've got my 3 boxes. Instead of figuring out, I've got 3 bags times 3 boxes, how many bags there are times how many sandwiches. I can figure out, look, I'm going to leave the boxes for the end, and I'm going to say, look, I've got 3 bags, and I'm going to multiply the bags, by the 4 sandwiches in each of the bags. And I could group it. I could do that part first. So I could figure out either how many bags there are first. I've got 3 boxes with 3 bags in each. That would be 9 bags times the 4 sandwiches in each bag. And that's, I can do my 9s trick. I don't know if we've learned the 9s trick yet, but if I do, let me back up here a little bit. If I've got my 9s trick, 1, 2, 3, 4, I'm going to put my 4th finger down to figure out 9 times 4 is, here's my 10s digit, 30. My 1s digit is 6. So 9 times 4 is 36. Or I could roll my 4s. All right, Dukes up. Einstein students, good as gold. Let me hear your 4s roll. 4, 8, 12, 16, 20, 24. That's how we roll our 4s. 28, 32, 36. I'm stopping because I did 4 times 9. I put up 9 fingers. It's 36. So that is one way. Or I can figure out how many sandwiches are in each box and then multiply by the 3 boxes. 3 times 4, I know that's 12. So there's my 12. This part here became this. And then I can do 3 times 12. Or I could think, if that seems stressful, 12 plus 12 plus 12. And I could add, oh, I know 12 plus 12 is 24. And then I could do, oh, 12 more than the 24. That's going to be 36. Okay? So there are 36 sandwiches that Clayton packed. That's a lot of sandwiches to make. Thanks for working on these problem-solving applications with me. Way to challenge yourself. Keep applying math.